Hello guys, welcome back. Thank you for joining me again. We're continuing our lessons from the AQA GCSE course. Today we are looking at the topic of electrolysis. As always, we're going to work that keyword methodically through this topic. We're going to start with our definition, our examples, a bit more advanced chemistry knowledge we need to know, then building into our final pieces of information, how we can identify what is taking place within this topic of electrolysis to identify a half equation for each part. Those quite technical, but if we work starting in our easiest part, our definition, down into our examples, incorporating our advanced terminology, and then using all this information to bring it all together, we'll be fine. We'll get them highest GCSE grades possible. Okay, so as always, definition, what exactly is it? Electrolysis, if you've done this in lesson, that is great to be able to define this. If not, electrolysis is the splitting. Sometimes you will see breaking up, decomposing, all these words acceptable, the splitting up of ionic compounds. There's that word again, we've seen our previous lesson, ionic compounds. What are we doing with? Using electricity. Wow. Sounds very technical, but taking our time, working step by step, we should be okay. As always, I hope you have paused this video before we begin, set it out in a template that we always use in the classroom, and hopefully we can work through this together. Online learning at its best, okay? So in front of us, what do we see here? Well, for the people that have done this required practical within the course, you would have done your electrolysis of your copper chloride solution. You would have used your electrodes. You have a charge upon your electrodes, and here you will have your electrolyte solution. The keywords, let's put them down so far. So, your electrodes. Your teacher hopefully would have mentioned this word, your electrodes. They are inert. It means they're unreactive. It's not going to contribute to any further reactions within this setup. Normally, they're made of graphite, and I would expect that within your classroom, wherever you are in the world, you would have used graphite electrodes within your electrolysis of your copper chloride solution. So here we have our electrodes, opposite charges, they are going to allow for the conduction of this electricity. Okay, another key term we want to be able to identify is what we call our electrolytes. Our electrolyte is this liquid solution here that our electrodes are sitting in, and our electrolyte here is our copper chloride solution. Okay, so nice introduction, electrolysis, what it is, basic overview if you can remember what you did in your practical requirement within your lesson. This is hopefully a nice recap for this. So you have your electrodes, you have your electrolytes. So let's make some space. So a bit more technical information. You can see that we have a positive charged electrode and a negatively charged electrode. Let's start developing and incorporating some different content we've done already. We want to be able to say that we're going to have the transfer of our electrons from our positive electrode to our negative electrode. Okay? How do we identify the names of these different electrodes then? So we have a very easy way in which we can remember them in chemistry. We don't want you to do this, we don't want you to panic, but when a chemist or a teacher of chemistry refers to this panic, they'll be talking about your electrodes within electrolysis. So, your positive electrode here. So we have our positive electrode, is called our anode. Perfect, we named that one. We have our negative one, so we have our anode, and we also have our cathode. There we go, so positive, anode, negative is cathode. Oh, nice and simple, alrighty then. Right, so recap once again, definition, key terminology relating to what you would have done in your lesson. So you have your electrodes, your graphite, they are inert, they are unreactive, they're not going to influence any further reactions, but when we're doing this electrolysis, we have our electrolyte solution, AQA, Edexcel, Cambridge, they will always refer to this copper chloride solution here, and now we have done our rhyme to identify the different names of these electrodes. Positive, anode, negative is cathode. Okay, perfect. So, on your piece of paper, you can label these in here. Now, if you want, I hope you have enough room for this. So on here, you can just write your anode. Whoa, let's do it down this way. Your anode and your cathode. Okay, perfect. Positive, negative. Right, so what is this all about then? We first talked about our electrodes. Yep, we've labelled this up, that is fine. Now we want to talk about our electrolyte solution, a copper chloride solution. So within here, copper chloride, we have our metal and we have our non-metal. So electricity passing through here, or a charge, is going to split up these ionic compounds. There we go, there's our definition. So we have referred to the splitting of this ionic compound using electricity. Going back to our knowledge of ionic bonding, the bonding between a metal and a non-metal, where does this name come from? Ionic compound. We're going to separate this solution, this electrolyte solution, into our metal and our non-metal. Perfect stuff. Okay. So what we're going to have formed in here then, when electricity is being passed through this electrolyte solution, we're going to have a situation where we're going to have this separation back into our ions, our metal ion and our non-metal ion. Have a look at the charges in which I've placed upon these ions here. I've separated for easy reckoning here. We have our metals on this side, our copper, and non-metals on this side, our chlorine. Think about what we talked about before about these opposite charges attracting each other, like charges repelling each other. Have a look at your diagram that you have created so far and see if you can identify to which electrode the ions are going to be attracted. You can pause the video now. Okay, so perfectly, hopefully you have identified your cathode here. Negative is cathode. So we're going to have this attraction from a positively charged, keyword cation, towards our cathode here. Oh, should we put any on there? Should we try and squash one in? Oh, cathode. Okay. And same situation again. We have our negatively charged non-metal, our anion, key term. If you've not seen the video on ionic bonding, lesson 1 on the YouTube channel, we are having this attraction to our anode. Why? Because we have this negatively charged ion being attracted to our positive charge. Nice, simple stuff. So, we've passed our electricity or a charge through our electrolyte. We can do this through our electrons being passed from our anode to our cathode, and this cycle continuing like this. We've broken up what we said. We said initially we had a copper chloride solution, our electrolyte. We have broken this up now into our copper ions and our chloride ions. Okay, so what are we going to be forming then? What is the point of this? So we want to, and hopefully you saw in your lessons when you did the electrolysis of this, the depositing or the forming of this pure copper upon this cathode. It forms like a brown kind of metal upon here. I'm sure you would have also seen this rhyme as well, oil rig and panic. Oil rig stands for oxidation is lost. What does this mean then? So oxidation is lost. Oxidation refers to the loss of electrons. Reduction is gained. So, two key rhymes for you to remember for electrolysis that will allow you to answer many, many different questions within these topics. Panic, how we can name our electrodes, and what is happening with our electrons within this process when we're splitting up this ionic compound. If you're struggling to visualize this, there's more lessons on the YouTube channel where we talk about this loss of electrons or this gain of electrons. Please watch the previous videos. It's not a race, we take our time, we go through this course together. So have a quick reflection if you are struggling to understand this concept so far. So oxidation is lost. So what is actually happening here? Reduction is gained. So if we think about our copper 2 plus charged ions, when they are joining this cathode, and if we look at this cycle here, we can visualize that our copper 2 plus ions, they are going to gain electrons. They want to become stable. They don't want to have a charge. They want a nice, stable copper. So what is going to happen? We have a 2 plus charge, meaning we have 2 more protons and electrons within this copper. In order to get rid of this charge, our copper is going to have to gain electrons. Positive 2 charge means 2 electrons to create this stable copper here. Okay, so we're going like this. Let's move this one up here like we just said. So we're going to have lots of copper that's being separated and start to be formed upon our cathode here. So let's put a little brackets here. Reduction is taking place for our copper. It is gaining electrons. Well, the opposite then. Oxidation is lost. If you visualize it once again, a negatively charged chlorine, negative charge, meaning it has more electrons being negatively charged, it's going to have to lose this electron here. So it's going to lose this electron at the anode. This electron that it loses is going to be passed on around in this cycle. So that's how this cycle is continuing to go round. Electricity is splitting our ionic compound. Chlorine then being attracted to the anode because it's positive, negative charge attracting, gaining or depositing this electron upon here and the electron going around. So oxidation is lost, oxidation is taking place for our chlorine. Okay, so that's what we need to know so far. We're probably working at about a grade 5 or 6 at the moment. Our final thing we want to be able to identify is our reduction half equation and our oxidation half equation. Okay, we're getting a little bit low now. Let me just take a stool down. Okay, so reduction half equation, oxidation half equation. If you can't remember what we're talking about, reduction is just referring to our equation, which is talking about what is happening with our copper here. Oxidation half equation, referring to what is happening with our chlorine. Okay, so let's go. So reduction half equation for our copper. We're going to have a situation where, as we mentioned before, we taught this through, Cu, 2 plus, it's going to gain our 2 electrons. And what is that going to do? That is going to be able to form our pure copper, which you would have seen in your practical. We're going to have this brown, it's like a brownish metal deposit. upon this electrode upon our cathode. Okay, now for our oxidation half equation. Get this right in your exam and we'll be going for very, very top grade. This is a little bit more difficult, and the products that we're forming will able for you, or you'll be able to state what gas is then being produced at our anode. Okay, so if we first identify, you might have tested for this in your classroom using blue litmus paper to test for the presence of chlorine. We're going to have a situation where chlorine gas is given off. Okay, we talked about oxidation taking place, the loss of electrons, and 2 electrons are going to be given off. Okay, we're just going to balance this up now. So we're going to have 2 negatively charged chlorines being deposited at the anode. This is forming our chlorine gas, which is then given off at 2 electrons, allowing for this cycle to continue round and round. So our final thing we want to say, coming out here as well, we're going to have a chlorine gas given off here, and we can test for the presence of chlorine gas using blue litmus paper. And you're going to have a colour change upon your blue litmus paper to show the presence of your chlorine gas. Forming upon your cathode here, let's just do a little more detailed diagram. A negatively charged cathode, you're going to have lots of copper deposited upon here. And I'm sure you saw this in your classroom. If you've not done this yet, ask your teacher, can you do this? Quite interesting to see. And if you've not done this yet, you'll be able to take this knowledge into the classroom to impress your teacher and impress your fellow classmates with your definition, your knowledge of these electrodes and the electrolytes, how to test for the presence of the gas given off at the anode or chlorine gas, your rhymes of how to remember what is taking place, how we can name our electrodes, positive anode, negative is cathode. Oxidation is lost, the loss of electrons, so chlorine is experiencing oxidation. Reduction is gain, so gaining electrons. So if we think our copper had a 2+ charge, okay? Why does it have a 2+ charge? My challenge to you is to go back to lesson 1 and look at this ionic bonding. Very high level question there. And then finally, our half equations for our reduction and our oxidation, showing the deposit of our pure copper, showing the release of our chlorine gas. Thank you very much for your attention once again. The link for this the link for my Google Classroom is in the notes under this YouTube video. Please join Google Classroom for more exam questions relating to the video here. Thank you for your time. Goodbye.